Okay, for this section, we are going to talk about using the double angles to help us solve, and cofunctions as well, to help us solve trig equations. So let's just go through and remind ourselves, cosine of theta, cofunction identities, co means complementary. Okay, so the cosine of 30 is equal to the sine of 60. So we could then say that another way to represent the cosine of 30, that's equal to the sine of 90 minus that 30. Okay, so the cosine of theta is equal to the sine of 90 minus theta, or the sine of pi over 2 minus theta. If we were going to be in radians, sine of theta is equal to the cosine then of 90 minus theta. Same thing, or the cosine of pi over 2 minus theta. The tan is equal to the cotan of 90 minus theta, or the cotan of pi over 2 minus theta. And I'm just going to go down through. Cotan's equal to tan of 90 minus theta, or, and I'm going to put little degree symbols there, or the tan of pi over 2 minus theta. Secant theta is equal to cosecant of 90 minus theta, or cosecant of pi over 2 minus theta, and cosecant is equal to secant of 90 minus theta, or the secant of pi over 2 minus theta. Those are your cofunctions, okay? So it's possible that if you were to see something like sine of 90 minus theta, you can replace it with cosine. The double angles, sine of 2 theta is equal to 2 sine theta cosine theta from our last chapter. There's 3 different cosine 2 thetas. We have 1 minus 2 sine squared theta. We have 2 cosine squared theta minus 1. And we have cosine squared theta minus sine squared theta. And then tan 2 theta is 2 tan theta divided by 1 minus tan squared theta. So again, those are our tools to use for these. So a couple of asterisk things. We're going to do substitution. We're not going to divide any functions out. Make sure that you factor or you use greatest common factor. GCF is a big one. Difference of perfect squares. Okay, square root both sides, plus or minus. Some things to think about. All right, first one. Cosine of 2 theta plus sine squared theta equals 1 should be replaced with something involving a sine so that we keep all the variables the same. So I'm going to use 1 minus 2 sine squared theta from up above. And then I'm going to rearrange it. So I'd have 1 minus 2x squared plus x squared equals 1. So I think what we get here is negative 2x squared plus x squared gives me negative 1x squared. I'm going to bring the plus 1 from the left-hand side over, and then I'm going to subtract the 1's from both sides. And those give me 0. So it looks like I'm left with negative x squared equals 0. And then I'm going to divide by negative 1. So it looks like x squared is equal to 0. So let's plug the sign back in. So we now have sine squared theta equals 0. We're basically looking at really where sine theta would equal 0. That would be the same thing. If you're trying to say x squared equals 0, well, just 0 times itself equals 0. So for this problem, we're just going to look at where sine theta equals 0. So I can think of the unit circle. I can use my calculator, but what I like to do is go around that unit circle and check them all out. So I'm going to do the sine of 0 degrees and the sine of 0 degrees. The y-coordinate is 0. There's an answer. And then I'm going to check the sine of 90. That's equal to 1. So no, that's not an answer. Then I'm going to check the sine of 180. So the sine of 180, that's equal to 0. Hey, there's another answer. And then I'm going to check the sine of 270. And the sine of 270 is equal to -1. So I have two answers for theta. They are 0 and 180 degrees. Remember, you can always go in and check this on your calculator. You can do cos 2 theta plus sine squared theta and y1 and y2 equals 1 and check out the intersections. And it should be 0 and 180. Next question. Okay, so 2 theta plus sine theta equals 0. So round answers to the nearest 100th degree. So we need a formula. Sine of 2 theta is equal to 2 sine theta cosine theta. And then plus sine theta equals 0. So all we did was a substitution for sine of 2 theta in green. When you multiply 2 times 2 sine theta cosine theta, you just simply get 4 sine theta cosine theta. So it's like saying 2 times x times y. It's not 4x times 2y. You don't distribute that 2. You just multiply the 2 and 2 and it's 4. So this is really 4. I'm going to let sine theta be x and cosine theta be y. So we're really just solving for xy plus x. Now, you might not think you can solve this because there's 2 different variables, but you can if you think about GCF, and that's the big key thing here. So we're going to factor out an x, and we're left with 4y plus 1 equals 0. So we really have x equals 0 and 4y plus 1 equals 0. So we have to remember that we associated sine with x and we associated cosine with y. So it's going to be sine theta equals 0 and 4 cosine theta plus 1 equals 0. Or you could have solved that and said cosine theta equals -1/4. So sine theta equals 0 we just did in the previous problem. So the measure of angle theta is equal to 0 and 180. So that part is done. Now we just need to contend with the cosine theta is equal to -1/4. So I'm going to do that over here. So I'm going to do quadrant, reference angle, sine. The quadrant is negative, so we're in quadrants 2 and 3. Now to find that reference angle, I'm going to show you if you do second cosine of -1 divided by 4, you do not get a reference angle. Reference angles are acute. So I'm going to do second cosine of +1 divided by 4, and I now get that reference angle. You could have just taken that 180, though, minus the 104.47, and you would have gotten, basically the reference angle that you needed as well. So it's giving you the answer in quadrant 2. If you want it, just get the reference angle. You have to ignore the negative for cosine. So our reference angle is 75.52. Now let me make sure I'm in the, yep, okay. So I'm going to go back 75.52. I'm looking for where I'm negative, so I'm going to do the measure of angle theta. This one says to the nearest hundredth of a degree. So I'm going to do 180 minus the 75.52. So I'm going to go back to second cosine 1 divided by 4 to get my reference angle, and then 180 minus that. So 104.48. And that was doing 180 minus the 75.52. And then for quadrant 3, I'm going to be doing 180 plus the 75.52. So to get my reference angle back, I'm just going to do 180 minus that 104, which answer I had, back to my reference angle, and then I'm just going to do plus 180 for quadrant 3. So 255.52. So there they are to the nearest hundredth degree. Okay, next one. Sine of pi over 2 minus theta plus cosine squared equals 1/4. So this one's again to the nearest hundredth of a degree. So this is a cofunction. The sine of 90 minus theta is equal to cosine theta. So it's really just cosine theta plus cosine squared theta equals 1/4. I'm going to next go and put it in some standard form. So I'd have cosine squared plus cosine minus 1/4. Now I'm not interested in factoring this, so I'm going to first write the x's, and then I'm going to get rid of that 4. To do that, I'm going to multiply both sides by 4 over 1. And so what that gives me is 4x squared plus 4x minus 1 equals 0. So we had to distribute that 4 to each term. And then I'm ready to factor. So let's take a look. Had one of these in 13.4's notes too, I believe. It's 2x minus 1 and plus 1. Oh, darn. That's not going to factor. They don't add to positive 4. They add to 0 in the middle there. So this tells me I have to use the quadratic formula. I actually knew this was going to happen. Just wanted you to make sure you realized that it did not factor. So we have A is equal to 4, B is equal to 4, and C is equal to negative 1. So x equals negative b plus or minus square root b squared minus 4ac all over 2a. So negative 4 plus or minus square root 16 minus 4 times negative 1 all over 2 times 4. So it's negative 4 plus or minus 16 plus 16, or 32 over 8. So I get x equals negative 4 plus or minus radical 32 all over 8. So I'm going to take that up here and do x equals negative 4 plus radical 32 over 8, and x equals negative 4 minus radical 32 all over 8. And I'm going to sneak in the cosine now. So it's going to be cosine theta equals, and I'm going to get the decimal. So negative 4 plus the square root of 32, enter, divided by 8.207. Okay, so I'm going to do this one right now, fresh in my mind. Quadrant's positive, so 1 and 4. Let's go back and get that reference angle. So second cos, second ans. So to the nearest hundredth of a degree, so 78.047. This is reminding me I'm positive, so the measure of angle theta so far is 78.05. And I have to do 360 minus 78.05, and that's 281 let's check out what that is. So I have to do 360 minus that, and I get 281.95. Okay, so far those are our answers. Now we got to look at the other side. So -4 minus square root 32 divided by 8. Now, this is a little fishy looking, because if I try now to do second cosine of that, even if I take away the negative, it's not going to, it's going to give me error domain, error, because cosine curves graph from -1 to 1. That's the range. And so this is one of those ones that we can say this side was -1.207, which just didn't work out. It was not going to give us a solution, so we have our answers, 78.05 and 281.95. Okay, I believe that that's it. For those, I am going to add one more onto this, a fourth example. And this one I tell you for sure will work out. It's 2 sine squared theta minus tan theta cotan theta equals 0. So we get 2 sine squared theta, and I would write that cotan theta as 1 over tan theta. So what's going to happen is those are going to cancel, giving you 2 sine squared theta minus 1 equals 0, or 2x squared minus 1 equals 0. I'd like to do these because kids forget the plus and minus. You get 2x squared equals 1, and then you get x squared equals 1/2, and then you get the square root of both sides, but you cannot forget that you have to do plus and minus. And when you do that plus or minus, you should then also multiply by 2 over 2, so you really get x is plus or minus radical 2 over 2. So we're looking to solve basically sine theta is equal to radical 2 over 2, and sine theta is equal to negative radical 2 over 2. So our reference angle is 45 for both, and we're going around all 4 quadrants. So theta's measure, the measure of angle theta, is 45, 180 minus 45, or 135, 180 plus 45 for quadrant 3 where it's negative, and 360 minus 45, which is 315 where it is also negative. So that concludes it. Have a great night.